Right. So let's move to the first MCQ that they have given in 2011-11. MCQ number 8. MCQ number 8. I believe that you tried these questions. If not, okay, let's do that one now. The mass of a sample containing strontium carbonate and barium carbonate is 0.8 grams. When the sample is dissolved in excess diluted acid, the volume of carbon dioxide gas liberated at standard temperature pressure is 0.112 cubic decimeter. The mass percentage of strontium carbonate in the sample, then they have given the relative atomic mass of carbon, oxygen, strontium, and right? Okay, right. So we have a sample with a sample containing strontium carbonate and barium carbonate. What is the mass of the sample? 0.8 grams. So they have dissolved this one in a diluted acid. Strontium carbonate and barium carbonate dissolved in diluted acid. For an example, just imagine diluted HCl, right? Then carbon dioxide gas liberated. So the volume of the carbon dioxide gas liberated is given as 0.112 cubic decimeter. They are asking what is the mass percentage of strontium carbonate in the sample, mass percentage of sodium carbonate in the sample, right? Now look at this one, how we can go for the answer. First, we know that strontium carbonate, now when it is reacting with HCl-like acid, it's producing strontium chloride and carbonic acid, H2CO3. Remember, carbonic acid is very unstable. It's a weak acid. So therefore, it's separated into carbon dioxide and H2. So they have given clearly carbon dioxide gas liberated. So when you dissolve strontium carbonate in a diluted acid, definitely carbon dioxide gas is liberated. Even for the barium carbonate, barium chloride is produced, carbon dioxide gas is liberated, NH2. To balance the reaction, we have to put 2 here. Now the total volume of the carbon dioxide, they have given 0.11. And they're asking what is the mass percentage of strontium carbonate. That's what they ask, right? The mass of sample containing only strontium carbonate and barium carbonate. So therefore, students, we can say that only strontium carbonate and barium carbonate, only strontium carbonate and barium carbonate. So therefore, mass of strontium carbonate is X. Let me take that one as X grams. Mass of barium carbonate is 0.8 minus X grams. Strontium carbonate mass is X grams. Barium carbonate mass is 0.8 minus X grams. Let me take like that. Okay. What is the molar mass of strontium carbonate? 88, carbon 12, oxygen 16 into 3 grams per mole. And I can say that 88 plus 12, 48, 148 grams per mole. What is the molar mass of barium carbonate? 137, carbon 12, oxygen 16 into 3 grams per mole. (197 grams per mole. Molar mass of barium carbonate, right? In this way. Remember, students, when you divide the mass by its molar mass, 148 grams per mole, you're obtaining the number of moles. Right? So tell me, what should be the carbon dioxide moles derived from strontium carbonate? X over 148. What is the carbon dioxide number of moles from barium carbonate? 0.8 minus 6 divided by 197 according to the reaction stoichiometry. According to the reaction stoichiometry. Now, we have to find out this X value. Look at this one. Huh? They have given that at the standard temperature pressure, carbon dioxide volume liberated from this reaction is 0.112 cubic decimeter. That is the carbon dioxide volume. Then you know that the molar volume concept, Vm theta, is equal to volume divided by the number of moles. Then we can find out the number of moles by number of moles by dividing volume by standard molar volume. So volume is 0.112 cubic decimeter. What is the standard molar volume? 22.4 cubic decimeter per mole. Right? Cubic decimeter cancel. Then here we have half into 10 to the power minus 2. That means 5 into 10 to the power minus 2. And so these are the carbon dioxide number of moles. Can you understand? Friends, they have given that standard conditions. So under the standard conditions, we can say that when you divide volume by its molar volume, you're obtaining the number of moles. So the carbon dioxide moles, number of moles is 5 into 10 to the power minus 3. So that should equal to the summation of these two neither. Summation of these two. Now we have obtained the carbon dioxide from another method, different method. By taking the mass of strontium carbonate, mass as X, I obtained the strontium carbonate number of moles. Using the reaction stoichiometry, I got that carbon dioxide produced from the strontium carbonate is X over 148. And barium carbonate mass is 0.8 minus 6. So therefore divided by its molar mass 197. Then we are obtaining barium carbonate number of moles. Then according to the reaction stoichiometry, I can obtain that carbon dioxide moles derived from barium carbonate is 0.8 minus 6 divided by 197. These two summations should equal to 5 into 10 to the minus 3. Then you can find out the expression. Right? So I can build up an equation like this. X over 148 plus 0.8 minus 6, 197. This is equal to 5 into 10 to the minus 3. Right? Okay, that's all. Now you have to find out the X value. Raise your hand, those who got the answer. So how did you take 22.4? You have to know that one. I told you, molar volume, they have given that the volume liberated at the standard temperature and pressure. Molar volume in chemical calculations we discuss, right? Any kind of a gas, 1 mole of any kind of a gas will have a volume 22.4 cubic decimeter at the standard temperature pressure. At the standard temperature pressure, any kind of a gas, 1 mole of any kind of a gas molecule will have this much of volume, 22.4. That's a constant value. So they have given the standard temperature pressure. Then we obtain the value like this. Simple. So raise your hand, those who understood up to now. Raise your hand, those who understood the calculation up to now. Do you have any doubts? Please tell me if you have any doubts. I know that this is not easy. This is not easy for all of you. but practice these kind of calculations. Nothing to worry. These things will be easy for you all. Continuously practice these things. That's what I have to say. Now we have to discuss more than 10 past exam questions. More than 10. So therefore, nothing to worry. You can get a lot of experiences by doing past papers. Right. Now I'm going to do the calculation to find out x value. X over 148 plus 0.8 minus x 197. This is equal to 5 into 10 to the minus 2. So what I'm going to do here is I'm going to take the common denominator as 148, 197. Then this is multiplied by 197x. And this is 148, 0.8 minus x, 5 into 10 to the minus 2. So then I have here 197x minus 148x plus 148 multiplied by 8. 38 3 here. So 118 point. So when you simplify this one, 49x. Do the calculations carefully. Yeah? 148 multiplied by 5. 197 and 74. Forty-nine x is equal to 145 minus 7, 145.78 minus 118.4. 27.38. X equal 27.38 divided by 49. But remember, we have to find out the mass percentage, right? Then mass percentage means X percent. 27.38 divided by 49. So the total mass is 0.8. Out of 0.8 grams, this is the mass of strontium carbonate multiplied by 100%. Right? Grams will cancel off here. Now you can go for the answer. Right? So hereafter, I think you have to go for the logarithm calculations. X percent strontium carbonate mass percentage is equal to So 49 multiplied by 8 is 39.2. Do the log calculations. $27.38. Thirteen means 4375. 39.2. 59.33. $8442. Antelope. 69.85. Do we have this kind of an answer? Correct. Yes, we have 70%, approximately. Approximately 70%. So question number 8, MCQ number 8, answer is third one. MCQ 8, answer is chemical calculation. Okay, 2011 A level. Na? So this is completely calculations. Can you understand this calculation? Please raise your hand, those who understood the calculation quickly. Do you have any doubts here? Please repeat these calculations again. Right, okay. Are we done? Shall we move to the next one? Then we have to go for the question number, MCQ numbers 28 and 29. So those are also calculations. Right, so let's start question number 28 and question number 29. Okay. Okay. Now they have given MCQ number 28. Capital A, solution prepared by dissolving 10.2 grams of pure potassium hydrogen thalate. Molar mass is 204 grams per mole, which is a weak monobasic acid in water, and then diluting up to 1 cubic decimeter. Okay, they have prepared a solution by dissolving 10.2 grams of potassium hydrogen thalate. Molar mass is 204 grams per mole in this way. Okay. Actually, the potassium hydrogen thalate, the compound is look like this: C double bond O minus A plus N. So, okay. So that is organic molecule. So let's write down this one as KHP, potassium hydrogen thalate. Okay. No need to know the molecular formula and everything. They have given the molar mass also, therefore nothing to do. So they have diluted this one up to 1 cubic decimeter. Then students, we can find out the molar concentration. So this is actually monobasic acid. Let me find out the molar concentration of this one. Maybe that will be useful for us for the future calculations. Mass is 10.2 grams divided by 204 grams per mole. So the volume is 1 cubic decimeter that they have taken. Then the answer is to here, and this is 0.1. 0.05 moles per cubic decimeter. So this is the molar concentration of the potassium hydrogen thalate, the solution that we have prepared, capital A. Okay. Then let's move to the capital B solution. Capital B solution, solution prepared by dissolving 2 grams of sodium hydroxide. Molar mass of pure sodium hydroxide is 40 grams per mole, containing an inert compound in water. Therefore, we can't find out the concentration directly here because inert compounds are there in the solution, and diluting up to 1 cubic decimeter. Anyhow, they have prepared a solution of sodium hydroxide 1 cubic decimeter by dissolving 2 grams of sodium hydroxide, but it's not pure, right? They have given that containing an inert compound in water. So therefore, we can't find out the final concentration yet. So therefore, let's keep this one as it is. Molar mass of pure sodium hydroxide is 40 grams per mole. They have given like this. Now let's go for the C, solution C. Concentrated sulfuric, concentrated HCl, molar mass is 36.5. Solution of density 1.2 grams per cubic centimeter, and the strength is 36.5. So we have discussed about these kind of calculations, right? When the density and the percentage is given, you can find out the molar concentration of the solution, right? Density is given as 1.2 grams per cubic centimeter. Molar mass of the compound is given as 36.5. grams per mole. Weight percentage is given as 36.5%. Sorry. Then can't you find out the HCl molar concentration? Very easily. (1.2 grams per cubic centimeter). Let me assume that the volume is 1000 cubic centimeter. Then this is the mass of the solution. In order to find out the HCl mass, we have to multiply this one by 36.5 divided by 100. Then when you divide this one by the corresponding molar mass of HCl, you are obtaining the number of moles. Cancel off. Let's consider the volume is 1 cubic decimeter. So therefore 1.2, sorry, 12 moles per cubic decimeter. So this is the molar concentration of the solution C that we have prepared. Then solution D. Solution D is prepared by diluting 10 cubic centimeter of solution C up to 1 cubic decimeter. They have taken 10 cubic centimeter. 10 cubic centimeter of solution C. Then students, we can find out that the number of HCl moles we have taken from that solution C. Molar concentration is 12, 12 moles per cubic decimeter. Volume is 10 cubic centimeter. That means 10 into 10 to the power minus 3 cubic decimeter. Per cubic decimeter will cancel off. Then the answer is 0.12 moles. Right? So they have diluted this one up to 1 cubic decimeter. So therefore, the new HCl concentration in D solution is the total value divided by 1 cubic decimeter. Answer is 0.1. That means molar concentration in the solution C is 12 moles per cubic decimeter. And by taking a sample of 10 cubic centimeter of solution C, they have prepared another solution of HCl which has a concentration 0.12. So these are the ABCD 4 solutions that they have given. These are the ABCD solutions that they have given. First of all, calculate these things on A solution, C solution, and D solution. We don't have to do the calculation yet in B. Get the summary quickly. We are still not going for the calculation yet, right? Students, raise your hand, those who understood the story behind this question number 28 and question number 29, the ABCD solutions that they have given. Raise your hand, those who understood the calculations that we did. Put your doubts in the chat box if you have any doubts. Okay, then let's go for the calculation. Question number 28. So let me write down here capital A is potassium hydrogen phthalate. Molar concentration is 0.05 moles per cubic decimeter. Capital B is actually unknown. Capital C, the calculated capital C concentration is HCl aqueous concentration. That is also C. Molar concentration is 12 moles per cubic decimeter. Capital D, HCl molar concentration is 0.12 moles per cubic decimeter. So this is the summary. And in the B solution, we know that 1 cubic decimeter solution which is prepared by dissolving 2 grams of sodium hydroxide in the solution in the water. There are some inert substances. Therefore, we don't know exactly how much of sodium hydroxide is there. Okay. Now let's move to the question number 28. A sample of 25 cubic centimeter of solution B requires 22 cubic centimeter of solution A for complete reaction. The purity of sodium hydroxide used to prepare a solution. Students, we know that potassium hydrogen phthalate is actually monobasic weak acid. That means it's kind of a reaction like sodium hydroxide and HCl. I can say that sodium hydroxide is reacting with potassium hydrogen phthalate with the reaction stoichiometry 1:1. Right? So they have given that the potassium hydrogen phthalate, the solution consumed to react with sodium hydroxide 25 cubic centimeter is 22 cubic centimeter. Right? So this is the acid and this is the base. Potassium hydrogen phthalate, the acid solution consumed, the volume of the acid solution consumed is 22 cubic centimeter. We know that the number molar concentration is 0.0. We calculate. And then we can find out number of moles of potassium hydrogen phthalate 0.05 moles per cubic decimeter multiplied by 22 into 10 to the power minus cubic decimeter. Cancel. 22 multiplied by 5. In 1.1 10 to the power minus 3. These are the potassium hydrogen phthalate. Then potassium hydrogen phthalate and sodium hydroxide reaction stoichiometry is 1:1. Then what is the sodium hydroxide moles reacted? 1.1 10 to the power minus 3. Can you understand? 1.1 10 to the minus 3. Remember, students, these are the sodium hydroxide in 25 cubic centimeter, right? Tell me, in the B solution, we have prepared a solution with 1 cubic decimeter, right? Then, in 1 cubic decimeter of that aqueous solution, how much of sodium hydroxide mole should be there? Okay? For 25 cubic centimeter, we have this much. Then for 1000 cubic centimeter, 1 cubic decimeter is 1000 cubic centimeter. How much do we have? Answer 1 cubic. Okay. Then the answer is 4.4 10 to the power minus 2 moles. Can you understand what I'm saying? Can you understand? Raise your hand, those who understood the calculation up to now. What are the doubts you have? If you have any doubts, put your doubts in chat box. Right. So these are the sodium hydroxide number of moles in the solution. Then what is the mass of sodium hydroxide? Number of moles multiplied by its molar mass. 40 grams. And the answer. (1.76 grams. Students, they have given that initially in the B solution, they have used 2 grams of sodium hydroxide. That means, is the sample that we have used, is that pure sample? It's not a pure sample. It's not pure sodium hydroxide. Sodium hydroxide amount is 1.76. And now they are asking what is the pure sodium hydroxide percentage? Pure sodium hydroxide percentage. Total mass was 2 grams. But in the solution, actually, they have a 1.76 sodium hydroxide. Exact. Multiplied by 100%. And you can see that the grams cancel out. 176 divided by 2. What is the answer? 80, 88% is the answer. Question number 28. Answer should be answer is number. Can you understand how did I do this time? It seems that 2011 is difficult. You think? In MCQ, we have to do this much. Huh? Tell me, students, if you want to share anything, you can share with me your ideas. So how we can manage time with these type of calculations? You have to manage that. Anyhow. The way that we can manage this by doing a lot of calculations. Because you have to do these calculations very quick. මේවා අතලලා ඉන්න බෑ පටපට ගාලා. දැන් මම explain කරනවා වගේ ඔයගලන්ට this is an explanation, right? So that's why we are taking this much of time. But when you are doing the calculation, you have to do that one quick. ඒකට ඔයා ගොඩක් calculations කරලා තියෙනවා. Right? Before you go for the exam, you have to do these calculations many times. Remember, one time of doing past papers is not enough. Right? You have to do some several times of past papers. You have to do several times. The way that we can manage the time is by doing a lot of calculations. Right. Now let's move to the MCQ number 29. So shall we find out the sodium hydroxide molar concentration? We found that the sodium hydroxide number of moles are 4.4 10 to the power minus 2 moles in 1 cubic decimeter. So therefore molar concentration is 0.044 moles per cubic decimeter. Right? Okay, now we know the molar concentration of all the ABCD solutions. 29. Volume of solution B required to react completely with 12.5 cubic decimeter of solution D is. In solution D, we know that HCl is there. Right? So this HCl is reacting with sodium hydroxide, simple acid base reaction to produce sodium chloride and H2. 1:1. Okay. Now, volume of solution B required to react completely with 12.5 cubic decimeter of solution. So can we apply here, since the stoichiometric ratio 1:1, C1V1 equals C2V2, number of moles are same. Right? So from the solution D, we are using 12.5 cubic centimeter volume. Molar concentration is 0.12, 12.5. So from solution B, 0.044 moles per cubic decimeter, volume is V. So V1 is equal to 12.5 means 25 divided by 2. Zero 0.06. 26 into 25 into 6. 1.5. That is 150 divided by 4.4. I think this should be 34 or 33 something, right? Let's see. 150 log value 2.1761, log value for 44 6435. So the difference is 6 here, 2. 5326 antelope. 34 9. Do we have that kind of an answer? Yes, approximately 34.1 cubic centimeter. MCQ number 29, answer is number 5. So these are the calculations in MCQ number 28 and MCQ number 29. So some interesting calculations, huh? Not bad. Raise your hand those who understood the calculation in MCQ number 29. That's very easy. That's very easy if you find out the molar concentration and everything in the previous question. Right? 28 is not easy. Right, okay. Then students, these are the MCQ questions that they have given in 2011 A-level paper. Now we can move to the essay question. Question number 8, part B, right? 2011 A-level essay question. Question number 8, part B. Let's see how we can do this calculation. Essay paper, question number 8, part B. Solution capital P contains sulfate, copper plus N, copper 2 plus N, H plus ions. The following procedures, 1 to 3, were used to determine their concentrations. So they have given 3 procedures one by one. So there is a solution. This solution is known as capital P, right? In the capital P solution, there are 2 cations, H plus, copper 2 plus, and 1 anion, sulfate, SO4, 2 minus. So they have conducted 3 different procedures to find out their concentration separately one by one. 2 cations are there, H plus concentration, copper 2 plus concentration, and they need sulfate concentration as well. So let's go for the procedure number 1. Excess barium chloride solution was added to a 25 cubic centimeter of the solution to precipitate sulfate as barium sulfate. So that means, students, when we add barium chloride for this solution, right? So let me write down here procedure number 1. In the procedure number 1, they have added barium chloride to this solution. Then what will happen? Sulfate anions are precipitating with barium. Then barium sulfate precipitate is produced. Remember, barium sulfate is white color precipitate, right? And chloride anions are now like this. The precipitate was filtered, washed, and dried till a constant mass is obtained. If there are water molecules, water vapor and everything, so we have to get the correct dry mass. So that's why they are doing this one. The mass of the precipitate was 2.335 grams. Determine the concentration of sulfate in the solution P in moles per cubic deciliter. Very easy, right? Friends, now we know that barium sulfate, first of all, what is the molar mass of barium sulfate? Barium 137, sulfur 32, oxygen 16 into 4 grams per mole. So when you take the summation, this is 233 grams per mole, right? They have given that the mass of barium sulfate precipitate that they have obtained was 2.335 grams. Then you can find out the number of moles of barium sulfate. Mass is 2.335 divided by 233 grams per mole. Grams will cancel. So 233.5. So approximately we can say that this is actually 233.5 divided by 233. 10 to the power minus 2 moles. 1 into 10 to the power minus 2 moles approximate. Okay. Barium sulfate moles. So according to that, sulfate moles are also 0.01 moles. Because we know that barium sulfate is made by barium 2 plus and sulfate. So therefore the sulfate molar concentration, barium sulfate molar concentration, both are same. Then how do you find out the sulfate molar concentration in the aqueous solution P? They have given that initially they have used 25 cubic centimeter sample. So then the 0.01 moles divided by the volume 25 into 10 to the power minus 3 cubic decimeter. Then the answer 10 divided by 25, 2/5. 2 over 5 means 0.4. Sulfate molar concentration is 0.4 moles per cubic decimeter. Raise your hand those who got the answer like this. 0.4 moles per cubic decimeter. Anyone here? Okay, very good. There are many. So shall we go for the marking scheme? How they have given the marks? For writing this molar mass, they have given 2 marks with the correct unit. For finding the number of moles of barium sulfate, they have given 3 marks. So therefore, finding sulfate moles, they have given 2 marks. For this calculation, they have given 3 marks. For the final answer 0.4, they have given 3 marks. For the unit, they have given 2 marks. So altogether, how many? 9, 9, 6, 15. So 15 marks is given for the procedure number 1, calculating sulfate molar concentration. It's very easy, yeah? It's not difficult. Quickly complete this one. We have to go for the procedure number 2. So quickly complete this. Right. Now let's move to the procedure number 2. Hydrogen sulfide was bubbled through 25 cubic centimeter of solution P to precipitate copper 2 plus as copper sulfide. Let's move to the procedure number 2. Now students, they have taken 25 cubic centimeter another sample. They have bubble hydrogen sulfide gas. Then hydrogen sulfide is reacting with copper 2 plus and producing copper sulfide. Copper sulfide, cupric sulfide. So this is a black color precipitate. Black color precipitate. And H pluses here. The precipitate was filtered, washed with water, and the filtrate was kept to use in procedure number 3. Now this precipitate is a foam. After that, now filtrate, that means the remaining solution. Remaining solution is keeping to use that one in the next procedure. Now we are taking this precipitate and let's see what they have done with this precipitate. Okay. So we have the remaining solution to do that one, to do the procedure number 3 in the next experiment. the precipitate was transferred into a titration flask. Copper sulfide is added for the titration flask containing 30 cubic centimeter of 0.28 moles per cubic decimeter acidic potassium permanganate. We have a titration flask. For this titration flask, copper sulfide, the precipitate is transferred. In this titration flask, they have given 30 cubic centimeter of potassium permanganate was there with the molar concentration 0.28 to produce copper plus, manganese 2 plus and sulfur dioxide. That means potassium permanganate is doing a reaction with copper sulfide. They have given the products also. They have given that it is producing copper 2 plus, Mn 2 plus and sulfur dioxide. So let me write down the reaction. Yeah, acidic potassium permanganate. So therefore I can write down here in acidic medium permanganate. Now I put their copper sulfide, the precipitate that produce. They have given that Mn2 plus produce, copper 2 plus is there and sulfur dioxide produce. And we know that exactly water also should produce because water is definite byproduct. So this is a redox reaction. Now we have to balance this redox reaction. How? Manganese oxidation number is +7 to +2. You can see that is the reduction. +7 to +2 reduction is by gaining 5 electrons. So can you tell me which one is oxidizing? So who is oxidizing here? Copper or else sulfur? Yes, sulfur, not copper. Copper's oxidation number +2 here. Here also +2. So therefore nothing changed in copper. Sulfur's oxidation number -2 here. Here sulfur's oxidation number is +4. -2 to +4. Increment is 6 electrons. In order to equalize the increment and decrement, I'm going to multiply this one by 5. Therefore, you have to put 5 here as well. And you are going to multiply this one by 6. 6 here and 6. How many oxygens are there? 24. Here we have 10. So 10 plus 14, that means 7. How many hydrogens then? 14 H pluses. So the overall charge is +8 here. Reaction is not balancing. Wait a minute. 24. So therefore we have to put 14 here, right? 14 water molecules. Then H pluses are 28 H pluses. Then overall charge in the left hand side is +22. Here +10, +12, +22. Now the reaction is balanced. Okay. So definitely in the marking scheme, they have given marks for this reaction. Let's see. Right. So now this is the reaction taking place after addition of copper sulfide precipitate that we obtained by the addition of hydrogen sulfide for the copper P solution. Right. Now they are giving that. And the excess potassium permanganate was titrated with 0.1 moles per cubic decimeter Fe2 plus solution. The burette reading at the endpoint was 10.5. That means they are giving a story like these, students. Now, if you know the potassium permanganate concentration and the number of moles, we know that we can find out copper sulfide moles. Using that one, we can find out copper 2 plus moles. Now, it's not the case. The case is actually, these are the total potassium permanganate in the solution. That means the potassium permanganate, they have added excess amount of potassium permanganate. That means a part of potassium permanganate reacted with this copper sulfide. Reacted with copper sulfide. And the remaining potassium permanganate, it is titrated against That means some part of potassium permanganate is remaining. So they have titrated that one with Fe2 plus. That means we know the total potassium permanganate that they have added. And we can find out the remaining potassium permanganate by doing a titration with Fe2 plus. Then only we can find out the potassium permanganate reacted with copper sulfide. See, it's not easy. Then let me write down the reaction between potassium permanganate, the remaining potassium permanganate reacted with Fe2 plus. For that one also we have a redox reaction. Fe2 plus is going to convert into Fe3 plus. We have discussed this redox reaction. This is very easy. Permanganate reducing into Mn2 plus, and both is definite byproduct. So here ions oxidation number is +2. Here ions oxidation number is +3. +2 to +3, you can see that increment is 1. Manganese is +7 here. Manganese is +2 here. +7 to +2, you can see that the decrement is 1. Then I can equalize increment and decrement. I'm going to multiply this one by 5. So 1 here, 4 water molecules, and 8 H pluses. Then the reaction is balanced. Right? Reaction is balancing perfect. Overall charge +17. So therefore 18 minus 1, 17. So the reaction is balancing. So they have given the consumed volume of this Fe2 plus is 10.5 and the molar concentration is 0.1. Then I can find out the Fe2 plus number of moles. 0.1 moles per cubic decimeter multiplied by 10.5 cubic centimeter volume. So 0.1 multiplied by 10.5, 10 to the power minus 3 moles. So answer is 1.05, 10 to the minus 3 moles. Fe2 plus moles reacted with this permanganate. Now mention the reaction stoichiometry between potassium permanganate and Fe2 plus. You have to mention these things. In the essay paper, you have to mention these things. What are the reaction stoichiometry? 5:1. Then we can say that the potassium permanganate moles reacted with Fe2 plus with 5 Fe2 plus, only one. Then with 1.05, 10 to the minus 3, how much? 2.1, 10 to the minus 4 moles. So these are the potassium permanganate moles that reacted with Fe2 plus students. Again, the total, right? Out of the total, from the total, this is the remaining amount. And we found the remaining amount as 2.1, 10 to the power minus 4 moles. So let me go for the marking scheme, how they have given the marks for these reactions and everything. For writing this redox reaction, they have given 5 marks. For this one also, they have given 5 marks. For calculation of Fe2 plus moles, for this one, they have given 2 marks. For the final answer, they have given only 1 mark. Oh, no. Yeah. And for this expression, they have given 2 marks permanganate moles. For the final permanganate moles, the reacted with Fe2 plus, they have given just 1 mark. That's all. Look at the way that they have allocated the marks, okay? Preferring marking scheme is actually very, very important. Now what we can do? Now students, we know that the total, right? Total potassium permanganate. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . total 0.28 moles per cubic decimeter multiplied by 28, sorry, 30 minus 3 cubic decimeter. And then the answer is 2.8 multiplied by 3. So this is the total potassium permanganate number of moles. Now we know the total, me. So the total potassium permanganate is 8.4, 10 to the power minus 3. Then how do you find out the potassium permanganate reacted with copper sulfide? Take the difference between these two. So I can take that number of potassium permanganate reacted with copper sulfide, CuS. This is equal to 84 into 10 to the power minus 4 minus 2.1 into 10 to the power minus 4. If not, let me write down 8.4, 10 to the power minus 3, 0.21, 10 to the power minus 2. So what is the difference? 8.4, 0.21. Take the difference. 9, 1. 8.19. 8.19, 10 to the power minus 3 moles. So these are the potassium permanganate moles reacted with copper sulfide. Now only we are coming to the point. Now for this calculation they have given 2 marks. For this number of moles they have given 1 mark. For this number of moles of potassium permanganate reacting with copper sulfide they have given 2 marks. Up to here. Quickly complete this one. Raise your hand those who understood the calculation up to now. Do you have any doubts here? If you have any doubts, put your doubts in the chat box. Huh? Now, students, potassium permanganate and copper sulfide reaction stoichiometry 6:5. Then the copper sulfide number of moles are, for 6 potassium permanganate, it is 5. For 8 into 8.19, 10 to the power minus 3, how much? These are the number of moles of copper sulfide. Okay. Then game is over. So if you know that copper sulfide moles are this, copper 2 plus cations moles are also this one. 5/6 into 8.19, 10 to the power minus 3. Then copper 2 plus was in the 25 cubic centimeter sample solution. Then copper 2 plus aqueous concentration 5 into 8.19 divided by 6, 10 to the power minus 3 moles. This is divided by 25 into 10 to the power minus 3 cubic decimeter. So these will cancel off, 1 here, 5. So 8.19 divided by 30 moles per cubic decimeter. So let me divide 8.19 by 3. Then 2 here. So we can get the answer like 0.273 moles per cubic decimeter. Molar concentration. Yes, there is the final answer. So for these steps, they have given for finding the copper sulfide moles. They have given 5 marks for this one. They're expecting us to simplify this one also, which means copper 2 plus moles here 3 marks. They are expecting us to simplify this one as 7 into 10 to the power minus 3. So approximately 6.8 10 to the power minus 3 moles. For that one also they have given 3 marks. For this division, they have given 3 marks. For the final answer, they have given 3 marks. For the unit, they have given 2 marks. So if you don't simplify this one, actually you are losing 3 marks. They're expecting the simplification also. So this is the way we can find out copper 2 plus molar concentration. Raise your hand those who understood the finding of copper 2 plus molar concentration. Do you have any doubts here? Good. All good. Right, okay. Then students, we can go for the last part of the question. So the last part is, now can you remember in the second procedure, we added hydrogen sulfide gas, copper sulfide precipitated, we removed the precipitate, and we took that one for the further analysis. So the filtrate that we use, that means the remaining solution. So the remaining solution, we kept the remaining solution to do another experiment to find out the H plus concentration. Now in the procedure number 3, we are using that remaining filtrate, remaining solution to find out the H plus concentration. So let's see what they have done. The filtrate from procedure 2 above was placed in a titration flask, boiled to remove hydrogen sulfide. So it is boiled to remove hydrogen sulfide and cooled to room temperature. To this, both 5% potassium iodate and 5% potassium iodide were added in excess. The volume of 0.4 moles per cubic decimeter sodium thiosulfate solution required to titrate the liberated iodine was 25. Determine the concentration of H plus in the solution P in moles per cubic decimeter. Right. Okay. Now, let's see what they have done to find out the H plus concentration in the solution. If you have any doubts, put your doubts in the chat box. Huh? So, what they have done, now in the solution, we know that H plus is there. Potassium iodate is added, IO3 minus. Potassium iodide is added, I minus. Can you remember this redox reaction? Can you remember this redox reaction? Iodate is reducing into iodine. I minus is oxidizing into iodine, producing H. So this is what happened. That 5% story, we don't worry about that one, right? We don't care. We only worry about the reaction. Now balance this one. -2 to 0. Increment is 2 electrons. +10 to 0. Decrement is 10 electrons. In order to equalize the increment and decrement, I'm going to multiply this one by 5. This is 10. Six 12H pluses. So we can simplify this one further, right? 6H pluses, IO3 minus, 5I minus, producing 3I2, 3 water molecules. Reaction is balanced. Then this iodine titrated with thiosulfate to produce tetrathionate S4O62 minus and I minus. Can you remember we discussed about this reaction under the neutral medium redox reaction? And I told you that every year they are giving this question, reaction. So to balance this one, we can put 2 here. 2 here. They have given the amount of sodium thiosulfate 25. Concentration is 0.4. Per cubic decimeter will cancel. 0.01 moles. Sodium thiosulfate and iodine reaction stoichiometry 1:2. That means iodine moles are half of that one. And this iodine came from this reaction. Then in that reaction, iodine and H plus unknown. We have to find out H pluses, right? Then iodine and H plus reaction stoichiometry is 1. 3:6. That means 1:2. Then the number of moles of H pluses will be again 0.01. Then H plus aqueous concentration, we took 25 cubic centimeter sample in the procedure number 2. These number of moles are divided by the volume 25 into 10 to the power 3. Then again we have 10 divided by 25. 0.4 moles per cubic centimeter. So this is the final answer. Let's see how they have allocated the marks for this one. For all the reactions, they have given 6. I think for this one 3, and for this one 3. Finding moles of thiosulfate, they have given 3 marks. For finding iodine number of moles, no, for finding H plus moles, they have given 3 marks. For this division, they have given 3 marks. For the final answer, they have given 3 marks. For the unit, they have given 2 marks. So that means 1, 2, 3, 4, 5, 6, 18, 20 marks are given for this. So this is what happened in the procedure number 3. So these are the calculations in 2011 A-level exam. Next week we can discuss 2012 unit number 2. Structure and bonding questions and chemical calculation questions.